For more information, please visit SGMAK Associates website.
Hi, here is another audio file on quadratic equation. I've numbered it as part 4. So we have a set of examples where finally the problem reduces to a quadratic equation and then you solve for the roots. And that has some relevance to the original problem that you started with. So look at the first problem. Here's an expression 2 plus square root of 3 raised to the power x squared minus 2x plus 1 plus 2 minus square root of 3x squared minus 2x minus 1 equal 2 over 2 minus square root of 3. We are not interested here how we got this equation. Question is, we recognize the unknown variable is x. It appears as a exponent in quadratic form, so you got to solve for the value of x here. So we make some simplification here as shown. 1 over 2 minus square root of 3 equals 2 plus square root of 3 because 2 squared minus square root of 3 squared is 1. So that's how you get. So you make the substitution and that gives us a quadratic equation of y, and it's shown here, the parts, you can follow through that. So it's a quadratic equation on y, and it's a perfect square, y minus in the bracket 2 plus square root of 3, then 2 bracket you close, square equals 0. So this quadratic has two identical roots, each equal to 2 plus square root of 3. So then you go back to the original equation. Substitute for y is 2 plus square root of 3. So that gives us that quadratic equation involving x squared minus 2x plus 1 equal 1. And again, it gives x squared minus x plus 2x plus 1 is 1. So x minus 1 whole square is 1. So, when you take the square root, you get two values for x, and they are either 2 or 0. So that's the first problem. Looking at the second problem, it says let alpha and beta be the roots of the equation x squared minus x plus b equals 0. So in that form, alpha plus beta, sum of the roots is minus the coefficient of a, so which is a, and product of the roots are b. Then you got to show that if an is alpha raised to the power n plus beta raised to the power n, then you show this a relationship between an and an plus 1 and an minus 1 holds. So it's just a matter of substitution. So what we do, we take the right hand side, a times an minus b times an minus 1. We substitute for an. So when you get an minus 1, you replace n with n minus 1. And you do simplification, and that comes out to be alpha raised to the power n plus 1 and beta raised to the power n plus 1. Only thing you to remember that when I multiply alpha with alpha raised to the power n, since base is the same and a multiplying power gets added. So that's how we get alpha raised to the power n plus 1 plus beta raised to the power n plus 1, which is equal to the relation given a n plus 1. So relation holds. If L and M are real and L, M are not equal, then the roots of the equation L minus mx squared minus 5 L plus mx minus 2L minus m equals 0. This roots of this equation, we want to comment on the roots. So we just find the discriminant of this equation, which is b squared minus 4ac. Always map the quadratic equation as ax squared plus bx plus c. So in this case, a is L minus m, b is minus 5 times L plus m, and c is minus 2 times L minus m. So discriminant is b squared minus 4ac, and what we get is we get an expression that is greater than 0. Since L and N are real and L they're not equal, so L plus M squared is positive, L minus M squared is less than L plus M, so this expression will be greater than 0. So if discriminant is greater than 0, roots are real and unequal. Okay. Solve 5 raised to the power x plus 5 raised to the power minus x equals log of 25 to the base 10. So when you have an exponent, it's better to do a substitution to convert into a simple algebraic equation. So we substitute 5 raised to the power x equals z. So we get z plus 1 over z is log 10, log of 25 to the base 10. That is a number approximately 1.4. So the equation becomes z squared minus 1.4 z plus 1 equals 0. And if you look at the discriminant of that, that comes out to be 1.4 squared minus 4 square root of that divided by 2 is less than 0. So the roots of the equations are imaginary, so there's no real solution for that equation we started with. Okay, next problem. Absolute value of x squared plus absolute value of x minus 6 equals 0. When you have a problem for this, absolute value should always return a positive value. So you got to see what happens when x is negative, positive, and what happens when x is negative. So you got to combine both conditions. So let's take what happens if x is greater than 0. Then the equation becomes x squared plus x minus 6 equals 0, has roots minus 3 and minus 2. And since x is greater than 0, so minus 3 we discard, x equal to 2 is a valid root. For x less than 0, the first term always returns a positive, but the second term we got to replace it by minus x. So that minus x is positive always, to be consistent with the absolute value of x, which is always returns a positive value. So we have the quadratic x squared minus x minus 6 equals 0. So roots here are 3 and minus 2, and since x is less than 0, so x minus 2 is the valid root. The two roots that we got, the sum of the roots is 0, and the product is minus 4. Pay attention to whenever you are dealing with the absolute value, you got to see what happens if the variable of interest takes value, or the expression takes negative or positive. So you got to combine both cases. Let's move on. If alpha and beta are the roots of the equation x squared plus px plus q equals 0, so then alpha plus beta will be minus p and product will be q. And then roots of x squared minus 4rx plus s equals 0, that roots are alpha raised to the power 4 and beta raised to the power 4. So if that's the case, then alpha, some of the roots will be r and the product will be s. Okay. Now you have another quadratic equation, x squared minus 4qx plus 2q squared minus r equals 0. So what are the nature of roots of this equation? So you always find out the discriminant first, so which is minus 4q squared, b squared minus 4 times 2q squared minus r. So we get 8q squared plus 4r. So based on the information given, it is greater than 0. Okay, so both are real roots, But what about the product of the roots? Product of the roots is 2q square minus r. So if you substitute q alpha beta in terms of alpha and beta is 2 alpha square beta square, and r equal alpha 4 plus beta 4. So if you simplify that, it becomes minus alpha squared minus beta squared within the bracket whole thing squared. So it's an expression less than 0. So what you are getting at, roots are real, but the product is negative. So one will be positive root, one will be negative. That will make the product negative. Okay. If x is real, then find the minimum value of the expression x squared minus 6x plus 5 divided by x squared plus 2x plus 1. So we do a simplification here. We take the expression, we subtract and add minus 1/3. So the equation stays equivalent. So then what you do, we factorize it, we keep minus 1/3 separate, and then we add 1/3 to that expression, and that gives us, through simplification, minus 1/3 plus 2x minus 4 squared plus 3 times x plus 1 squared. Now minimum value of this expression, since the second part is a perfect square, the minimum value will be 0, and that will take place at x equal to 2. So the minimum value of this expression is minus 1/3 at x equal to 2. Okay. All right. If alpha and beta are the roots of the equation x squared plus bx plus c equals 0, and alpha plus h and beta plus h are the roots of the equation px squared plus qx plus r equals 0. So then from the first equation we can say some of the roots, alpha plus beta is minus b over a, alpha times beta is c over a. From the second equation we can say alpha plus beta plus 2h, which is sum of the roots, is minus q over p, and the product of the roots are r over p. So then we can find the value of h by simplification, and we can see that alpha minus beta whole square is alpha plus beta square minus 4 alpha beta, which is given by b square minus 4ac over a square. And same expression we can get if we take alpha plus h minus beta minus h. Difference of the roots from the first equation and difference of the roots from the second equation, they are the same, and that gives you two separate expressions. They should be equal. So b square minus 4ac over a square should be equal to q square minus 4pr over p square. All right. Next equation, I, imaginary number I square is minus 1. Ix square minus 2 times 1 plus I, x plus 2 minus I is 0. It says 2 minus I is one of the roots, find the other root. So if you form a standard form, we say x square minus, we divide both sides by I, so we get x squared plus 2 times I times 1 plus I, x minus I times 2 minus I equals 0. Remember, I squared is minus 1. So some of the roots are minus 2I times 1 plus I, and product is minus I, product is minus 2I plus minus 2I, product is minus I times 2 minus I. So as you can see, some of the roots are 2I, 1 plus I can be simplified as minus 2I plus 2. So that can be written as 2 minus I minus I. One of the root is 2 minus I, so other root has to be minus I. Because that also validates product of the root as minus I times 2 minus I. All right. Last problem for this batch. If P and Q belongs to real numbers and 2 plus I times square root of 3 is the root of the equation x squared plus px plus q equals 0. Now quadratic equation has two roots. If one is imaginary, other will be complement imaginary number. So if one root is a plus ib, other root has to be a minus I times b. So in this case, other root has to be 2 minus I times square root of 3. Imaginary roots always occur in pairs. So sum of the roots, if you take, is minus p, which is in this case 4. So p is minus 4. Product of the root is q, which is 2 plus I square root of 3 multiplied by 2 minus I square root of 3. So that comes out to be 7. So p is minus 4 and q equals 7. So that's this part, sequence of 10 problems on quadratic. Again, if any question, email shows here. Get in touch with us. Okay, bye now. Hi, we are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.